Soldering is a method of connecting together metal pieces in such a way that they are both mechanically connected, in other words, you can't easily pull them apart, and also electrically connected, in other words, current can flow easily between them. We do this by using a hot iron, called a soldering iron, to melt a low melting point metal, known as the solder, and then applying the melted metal to our components. When we remove the iron, the melted metal cools and becomes solid again, thus securing the metal pieces together. Soldering is a great skill to have in general, but it is an especially important skill for an aspiring robotics engineer. Some of the parts in your kit need to be soldered, so in this video I'm going to lead you through the process of how to do this. Start by laying out the pieces. There are only two things that we're going to solder today, your P-socket and the LCD screen. The thing we're going to solder on to the P-socket and the LCD screen are these little pieces here that are called headers. Start by putting the header through the P-socket holes as shown here. I want you to notice a couple of things that I did here. First of all, I made sure that the header is pointing up on the P-socket. You can tell which direction is up by looking at the little micro USB port on the back of the P-socket. The micro USB port is sitting on the top of the P-socket. So the header should be placed on the same side of the P-socket as the micro USB port. Secondly, I lined up one end of the header with the bit of perforation on the P-socket. So the header should be hanging off the back end pretty far. There are some holes on the P-socket that are on the piece in front of the perforation, and we're not going to solder any headers to those holes because we're not actually going to use those pins. So line up your header as I've shown here. Then use a wire clipper or a side cutter, or even a good scissors will work here, to clip off the end of this header. When you do this clipping, you're going to lose one pin from the header, and that's okay. Save the piece that you just cut off, because we're going to use that piece of header later on to solder to the LCD screen. So now we'll do the same thing with the other piece of header. Line it up so that you know where to cut it, and then cut it right flush with the back of the P-socket. Now I'm going to place my two header pieces through the two sides, and I'm going to set it upside down like this. Wiggle it a little bit to get it straight. So notice right now that the way this P-socket is sitting, the top of the P-socket, that is the side that has the micro USB port, is pointing down towards the table. I'm also going to get the LCD screen set up right away. We don't need to use all of the pins of the LCD screen. So we're going to clip this header once again. Take one of the pieces of header that you clipped off and count 6 pins on this header and place those 6 pins through 6 holes on the P-socket. We're just going to use the P-socket as a thing to help us cut this header in the right place. So place 6 pins through 6 holes, and then use a clipper or a scissors to clip off the back. So you should be left with 6 pins still intact. Then place this through the holes on the LCD screen like this. Now we need to do this same thing with the other side of the LCD screen. Luckily, the piece that you just clipped already has 6 pins. So take the remaining 6 pin piece and put it through the other side of the LCD screen. Then I'll put the P-sock back together like this. So if you have these set up the right way, the LCD screen should be pointing down, with the headers also pointing down towards the table and the pins sticking through the holes. The P-sock should also be upside down, meaning that the micro USB port is pointing down towards the table. Okay, now we're going to go ahead and get the solder. If you have a soldering iron that is an adjustable temperature soldering iron, you want to set the temperature of your soldering iron to be as low as you can have it and still melt the solder, and that temperature is around 700 degrees Fahrenheit. If you have a soldering iron that just plugs into the wall, it's probably set to try to heat to about this temperature, which is a good recommended soldering temperature. Now, I mentioned before that solder is a low melting point metal. Typically, solder is a mixture of the metals tin and lead, and you can get solder in different combinations of amounts of tin and lead. Here, I'm using a 63-37 combination, which I particularly like for soldering circuit boards like this. You can also get your solder in different diameters of the solder. And here I'm using a 0.5 millimeter diameter, which is also a personal preference. This solder has something called a rosin core. Rosin or flux are two materials that are used for helping solder to adhere to the two metals that you're trying to solder together. So using a solder with rosin core can often work out easier than if you did not have the rosin. If you're using a soldering iron that just plugs into the wall, plug in your soldering iron and give it a little bit of time to heat up. If you're using an adjustable temperature soldering iron, turn it on using its on switch and we'll begin soldering. The first thing you're going to do is something known as tinning the tip. Use the soldering iron to touch directly to the solder and just hold it there for a little bit until some solder gets melted onto the tip of your soldering iron. Doing this, especially the very first time you use a soldering iron, will help protect the tip from becoming oxidized and then losing its ability to heat. So the very first thing you should do with your soldering iron the first time you use it is immediately apply some solder to the tip of the soldering iron. This is also a good way to tell when your soldering iron has gotten up to temperature. Once the solder melts when you touch it to the tip of the soldering iron, you know that your soldering iron is hot enough. Once you've done that, take the tip of your soldering iron and touch it to the joint right where the little pin comes through the little hole on your P-sock. Try to touch both the pin and the little copper pad at the same time with the end of the soldering iron. We're trying to heat both parts simultaneously because the melted solder will flow and adhere much better to hot components than it will to cold components. So we want both of the things we're soldering together to both become hot. Now take the line of solder and touch it also to the place where your soldering iron is touching the joint. So in other words, the tip of your soldering iron should be touching 3 things at the same time: the little copper pad, the pin sticking through the hole, and the line of solder. Because you took the tip of your soldering iron and touched it to parts that are cold, it'll take a little bit of time for all of the parts to get back up to temperature. Once it does get back up to temperature, the solder that you're touching the soldering iron with will melt, and the melted solder should flow into the joint. Let's take a close-up look at what I'm doing here. So I touch the tip of the soldering iron to 3 things at the same time. And now my soldering iron is hot already, so the solder starts melting almost immediately. As soon as the solder has flowed in and you've gotten a tiny blob at the joint, you want to remove the soldering iron right away. And don't leave it there any longer than necessary. If you leave the soldering iron at the joint too long, you run the risk of actually melting other components in your circuit board that you don't want to melt. So we're going to try and complete each solder joint as quickly as we can. Now, just watching me solder here is going to get tedious very quickly, so I'm going to fast forward until I complete this, and I'm going to show you my solder joints at another angle. Okay, let's take a closer look at these solder joints. After I'm finished, I'm going to look at them from the side like this, and I'm going to look for any solder joints that don't look quite right. For example, there's one here. Let me see if I can point it out to you. This joint right here looks like it doesn't have enough solder. So I'm going to go back and do this one again. There we go. When we look at these solder joints from the side, we want them to look as if they're a tiny bit concave. So if I pause the view here, this solder joint right here looks like an ideal solder joint. Do you see how we have a peak at the top and then a concave joint? You would prefer to have this kind of a solder joint compared to this one over here. On this solder joint, I put a little too much solder, and so I've created a little what looks like a mountain of solder instead of like a volcano of solder. The joint will still work, it just has more solder than what you actually need. Okay, now that I see that all of my joints look okay, I'm going to go and solder the LCD screen. So take a moment here to look at how my LCD screen looks to make sure that you have yours set up the same way. I have 6 pins poking through the 6 leftmost holes, and I have 6 pins poking through the 6 rightmost holes. The 4 holes in the center are pins that we don't need to use in order to get the LCD screen working, and that's why we've set it up this way. So if you have yours set up in the same way, go ahead and solder these 2 headers on. Check your joints from the side view after you're done. And when you're finished, it should look like this. You should have the 6 leftmost and the 6 rightmost pins now available with headers. There is one more assembly step that we need to look at before we're finished setting up our kit. Your baseboard might have come completely assembled for you, or there might be one or more steps that you need to complete. A completely assembled board has on the bottom little feet, little rubber feet that allow it to not slip when you place it on a surface. And it also has these 2 sheets on top of it. One sheet that's printed and another sheet that gives it a dry erase surface. There's also a pattern of holes drilled into the bottom of the board. If your board is completely assembled, that is, it has the dry erase surface and the printed pattern on the top, it has the feet on the bottom, and it has the holes drilled, then you don't need to take this step. If your board is not completely assembled, I'm going to show you now how to put your board together from its pieces. If your board is not completely assembled for you, start by finding these 4 pieces in your kit. A wooden board that looks like this, a little strip of 5 rubber feet that looks something like this, and 2 sheets, one sheet that's printed and one sheet that's clear. We're going to start with the printed sheet. The printed sheet is adhesive on the back, and we want to stick the sheet to the top of the board. Start by peeling off half of the backing of the printed sheet. Then line up the adhesive with one end of the board. Once you have it lined up, stick this one end down to the board. Then fold back the other side. And as you peel the adhesive off, press the sheet down to the board. This pattern that is printed on this sheet will help you in the projects that we do to figure out the XY location of the end effector. Each of these 2 lines is 1 centimeter away from the line next to it. The position here where all of the lines intersect is the point that we will use as x equals 0, y equals 0 in our projects. Each of these angle lines is 15 degrees away from the line next to it. So this line here is the 0 degree line. This one is 15 degrees, 30 degrees, 45, 60, 75, 90, and so on. These circles here are a hole pattern that will allow you to mount different components to the board. Now, we want the surface of this board to have a dry erase surface that will allow us to do projects where we make the arm draw on the board and will allow us to draw coordinate frames on the board. So this sheet here is a dry erase surface that you can stick to the top of the board. So flip this sheet over and peel off just the small piece of the backing, revealing a small clear strip. Now, the adhesive surface is a little bit bigger than the board, so you don't have to line this up extremely well. But if you try to get it lined up as well as possible, it'll make less work for you in the next step. So try to line up the adhesive sheet with the edge of the board and then stick it down. The same way you did with the other adhesive sheet. Now, peel this back, and as you peel off the backing, use your other hand to smooth down and adhere the surface to the board. This will help remove air bubbles as you go. When you're finished, you'll have some extra surface, dry erase surface on the two sides. You can either fold this over or you can cut it off with a scissors or an X-Acto knife. Next, use a 3mm drill bit to drill the holes indicated by this circle pattern at the bottom of the board. Lastly, we're going to stick the little rubber feet onto the board. Flip the board over and peel off the little feet, sticking one to each corner and one right in the center. Now, your kit is all set to go.